Stop! Do not press that WD-40 nozzle. One wrong spray can wreck the part instantly. Most drivers think this stuff is harmless, but one wrong move can instantly destroy wiring, crack rubber, ruin sensors, or even spark a fire. And the worst part is that the damage starts the moment it hits the surface. So hear this, before you touch that can, keep watching, because there's a surprise at the end that everyone gets wrong. Number 7. Brake pads, rotors, and calipers. Brakes only work when every surface can grab the moment you press the pedal. The pads, rotors, and calipers need clean contact, and anything oily ruins that balance instantly. WD-40 feels like a helpful product, but it behaves in the worst way on brake parts. It leaves a thin film that spreads fast. That film turns strong friction into slippery contact that never feels safe. The biggest problem starts with the pads because they absorb whatever hits them. When WD-40 reaches them, the material soaks up the oil and loses the bite it depends on. The pedal begins to feel loose, and the braking power drops without warning. Stopping distance increases, and the whole system reacts more slowly under real pressure. Once that oil settles inside a pad, it rarely cleans out, and the pad becomes unreliable. Rotors also change because the residue spreads as they heat during regular braking. That creates patchy contact, which sometimes leads to vibration or a glazed surface. Heat builds quicker. The brakes lose strength during longer drives. Calipers can suffer as well because the product can reach the rubber seals inside them. Those seals protect the pistons, and they weaken when exposed to petroleum-based products. That leads to sticking pistons and uneven braking that wears everything down faster. The scary part is how fast WD-40 travels once the wheels start moving. A small amount in one area spreads across the rotor with each turn. When that happens, the only real fix is replacing the pads and restoring clean surfaces. And if clean surfaces matter there, belts hate WD-40 even more. Number 6. Engine and accessory belts. Engine belts sit right in the center of everything your engine tries to run. The alternator, the water pump, the power steering system, and several other parts depend on one strong belt that grips and spins without slipping. That belt is designed to run dry because friction keeps the whole system moving with steady power. When a belt starts squeaking, it sounds annoying, but the noise usually means wear or tension problems, not dryness. This is where people reach for WD-40 because it feels like a quick fix. It will stop the noise for a moment, but it also creates a slick surface that removes the grip the belt needs. The belt starts slipping on the pulleys, and the engine begins working harder than it should. The alternator may charge less, the water pump may slow down, and the steering can feel heavier during sharp turns. The short silence comes with real consequences under the hood. There is also the rubber itself, and modern serpentine belts use compounds that react to certain chemicals. WD-40 can weaken the material with repeated exposure, and the belt begins to crack earlier than normal. A worn belt does not give many early signs. Failure usually happens without much warning. When a belt snaps on a running engine, several systems shut down at once, and that can leave a driver stranded. Mechanics point out that squeaks usually come from worn pulleys, weak tensioners, or belts nearing the end of their life. Those parts need repair, not coating. A healthy belt stays dry, grips well, and lasts longer without chemical sprays that damage the surface. If sprays harm surfaces, let's just say they become deadly on exhaust parts. Number 5. Hot exhaust components. The exhaust system deals with some of the highest heat your car creates. The manifold, the catalytic converter, and the pipes get hot fast and reach temperatures that surprise most people. These parts stay exposed to constant heat because the exhaust comes out of the engine with intense energy. That is why they stay bare metal and why they cannot handle anything that leaves an oily surface. When someone sprays WD-40 on these parts, the situation becomes risky the moment the engine warms. WD-40 contains petroleum-based ingredients that react aggressively to high heat. The product might look harmless when it goes on, but the film stays on the metal until the temperature rises. As the exhaust system heats, the residue begins to smoke and produce sharp fumes that travel through the engine bay. The smell alone can worry a driver before anything serious happens. The danger grows when the surface reaches the point where the residue can ignite. The hottest part is always the catalytic converter, and it reaches temperatures that push every material around it. A flammable film on that surface becomes a real concern because the heat stays concentrated. The residue can smolder under shields or around bolts before burning away. Exhaust pipes can also develop uneven burn marks when the film cooks, and those marks can speed up corrosion later. Even if flames never appear, the product leaves a sticky layer that collects dirt and holds heat against the metal. That buildup makes future work harder and raises stress on the exhaust system over time. A system built to handle heat needs clean metal, not a coating that reacts to it. And no coating reacts worse than one inside a MAF sensor. But before we dive into that, make sure you hit subscribe so you stay ahead of the mistakes that ruin parts fast. Number 4. Mass airflow sensor. MAF sensors sit in a very sensitive part of the intake system and handle precise work. They measure how much air enters the engine so the computer can adjust the fuel with accuracy. That small sensor keeps the entire air and fuel balance steady, and even tiny changes can throw things off. The surface inside the sensor is extremely fragile, and it cannot handle anything that leaves residue. This is why mechanics stay firm about what should touch that part. WD-40 becomes a problem because it never dries in a clean way. It leaves a thin, oily layer that clings to the delicate element inside the sensor. Once that film settles, the sensor starts reading air differently, and the fuel mix shifts away from normal settings. The engine may idle roughly and lose power during acceleration. Fuel economy can drop because the computer thinks the engine needs more fuel than it actually does. Drivers often chase strange symptoms without realizing a contaminated sensor started everything. Some sensors recover with proper cleaners, but many lose accuracy after repeated exposure. Electronics cleaners and MAF-specific sprays evaporate without residue and protect the delicate wires inside the housing. WD-40 does the opposite because it traps dust and changes how the sensor reacts to airflow. The buildup grows with time and turns a small mistake into a costly repair. Forums, technicians, and guides all repeat the same advice because they see the damage often. Sensitive sensors need dry surfaces and approved cleaners, not an oil-based product that changes readings. Keeping the intake system clean requires careful products that never leave a trace. No trace belongs there, and oxygen sensors demand the same. Number 3. Oxygen sensors and exhaust sensors. Oxygen sensors work in one of the most important zones in the entire engine. They track how much oxygen moves through the exhaust stream so the computer can control fuel with precision. These sensors depend on clean surfaces because the chemical process inside them is extremely exact. Even a thin layer of contamination can alter their readings. It also creates problems that spread through the whole system. WD-40 becomes a major issue because it burns into a carbon-heavy film. That film settles on the surface of the sensor and blocks the contact it needs with the exhaust gases. Once that layer forms, the sensor begins sending distorted signals to the engine computer. The engine adjusts fuel based on those signals, and the mixture drifts away from normal balance. Drivers feel this through rough idling, weak acceleration, and fast drops in fuel economy. Overspray can also enter the intake stream, and the burned vapor moves straight to the sensor. That vapor leaves small particles that collect on the surface and change the way the sensor reacts to heat. Technicians warn people about this because they see the same pattern every time. The readings break down, the computer adjusts fuel incorrectly, and the engine loses efficiency with each drive. As the residue hardens during repeated heating cycles, it forms a layer that cannot be removed. A coated sensor becomes unreliable and often stops working altogether. When that happens, the computer shifts into a protective mode that limits performance. An engine that depends on accurate signals cannot run well with a contaminated sensor. Keeping sprays away from any air or exhaust path protects the entire system from long-term damage. And rubber is where that damage shows up next. Number 2. Rubber component. Rubber parts in a car deal with constant movement, heat, pressure, and vibration. They stay flexible for years. That's because they are built to bend, seal, cushion, and absorb impact with steady strength. These parts work well as long as the rubber stays healthy, and that depends on keeping the material away from products that break it down. This is where trouble starts when someone reaches for WD-40. Rubber reacts badly to petroleum-based sprays because the liquid slowly enters the surface. WD-40 creates a soft feeling at first, and that tricks people into thinking the part looks refreshed. The rubber then loses its natural strength when the oils sit inside the material. As the oils evaporate, the rubber stiffens and forms small cracks that grow with time. Bushings and engine mounts begin losing their shape and stop absorbing vibration the way they should. Belts also suffer because the spray reduces grip and weakens the material once heat builds. The belt starts slipping on the pulleys, and the noise returns with more wear than before. Hoses take the damage even faster because they face pressure and temperature changes every time the engine runs. The rubber begins to dry, swell, or split near clamps, and a simple leak can become a sudden failure. Weather stripping around doors and windows reacts the same way. The spray removes the protective layer that keeps the rubber soft, and the material becomes brittle with use. Silicone-based products avoid these problems because they protect instead of breaking down. Using WD-40 on rubber slowly shortens the life of every part it touches and creates repairs that never needed to happen. Well, those pointless repairs are nothing compared to ruined bearings. Number 1. Wheel bearings and other greased bearings. Wheel bearings deal with some of the toughest conditions on a vehicle. They carry the full weight of the car, keep the wheels spinning smoothly, plus handle pressure every second the vehicle moves. They rely completely on the thick grease packed inside the housing, and that grease forms a cushion that separates the metal surfaces. When that grease stays healthy, the rollers glide, the races stay smooth, and the bearing lasts a long time. WD-40 creates real problems the moment it enters this system. It is thin, it spreads fast, and it behaves more like a solvent than a lubricant. Once it reaches the bearing, it begins to thin the grease that protects the metal. The rollers lose their film of cushioning, and the surfaces start touching each other under heavy load. When steel meets steel without grease, heat rises fast, and the damage begins with small marks that grow with time. The thin residue left behind by WD-40 cannot handle the temperature inside a busy hub. It evaporates quickly and leaves the bearing dry. A dry bearing becomes noisy, overheats, and can fail without warning during normal driving. Specialists warn that even a small amount of solvent can shorten the life of a bearing because modern greases depend on precise chemistry. Serviceable bearings face another problem because WD-40 removes additives that prevent rust and moisture damage. Sealed bearings suffer too because the spray can slip past failing seals and dissolve grease with no way to replace it. A wheel bearing needs steady, thick protection, not a solvent that removes everything designed to keep it alive. And that's everything you need to know to avoid the WD-40 disasters people never talk about. Did you find this video helpful? Tell us in the comments. And don't miss the next video because it exposes another common quick fix that destroys your car even faster. Watch it before you learn the hard way. Thanks for watching.